So the next problem, and I think just for the example that I gave you guys, I think this ends up being a little bit dicey. So I'm going to show you a couple of different ways of how to get this because I don't know if my graph is going to be big enough for this particular problem. So we'll do our best here. So if I'm going to solve a system of equations by graphing, remember we're looking to see if our equations are going to intersect. So if they intersect, that would be our solution. Remember, if they're kind of laying on top of one another, that means we have infinite solutions, and if we have two parallel graphs, we have no solutions. So I'm going to deal with the bottom equation just because that's a lot easier, and when I'm graphing, I want things to be in slope-intercept form. So all I have to do is subtract x, and I have y equals negative x plus 5. Okay, so I have a y-intercept of 5 and a slope of negative 1. So I should be able to graph a straight line through those points. Now my second one is going to be a little bit more work, but not too much. So minus 2x minus 2x. So we have negative 3y is equal to negative 2x plus 5. Divide by negative 3. Maybe this won't be too bad. So we get y equals 2/3 x. 2/3 x minus 5/3. So that part's kind of gross. So minus 5/3, that's 1 and 2/3. So if I'm going up 2, I have to keep that point in mind that I'm actually at the going down 1/3 from the value. So that's going to be 1, 2, 1, 2, 3. So it's going to be something like that. And I feel like I'm kind of off there because I think I see where the point should be. And I think it should be right there. And just to be sure, so that's at 4, 1. Is that intersection point. And just to be sure, I'm going to plug those values in. So with my simple equation here, negative 4 plus 5 is definitely 1. And for my equation up here, 4 times 2/3, so that's going to be 8/3 minus 5/3 is definitely 3/3, which is also 1. So this point will be what we're dealing with. Not as bad as I thought.